All right. So do you have a preference on which sheet you wanted to go through? Tuesdays, Wednesdays, or today's?
Let's do today's.
Today's. All right. Open that one up. All right. Send a notability. All right. All right. So today's practice sheet. All right. So let's look at number 1. It says calculate the number of moles of sodium hydroxide. Oh, sorry, that's moles. All right. Number 2 is a full problem. Number 2 goes through the whole thing. So it says calculate the mass of.
We're doing the same thing though, right?
Yeah, same thing, just multiple steps this time.
Oh, okay.
So it says calculate the mass of NH3 that can be produced from the reaction of 125 grams of NCl3 according to the following reaction. All right, so we have our balanced equation below. And it says we're trying to go from grams of NCl3 to grams or mass of NH3. So we're trying to figure that one out. We're starting with grams of NCl3, and we're trying to get 2 grams of NH3. Now, do you remember the 2 conversion factors that we've talked about so far?
All
right, so I'm gonna write them way up here, okay? So we talked about doing 2 things. We talked about going from moles.
Moles to grams.
Moles to grams, perfect. Moles to grams of the same compound. And we talked about going from moles to one other thing.
To molar mass, mole ratio? I don't know.
So mole ratio, perfect. So we talked about going from moles of one compound to moles of a different compound. So we talked about going from moles to grams, and we talked about going from moles to moles. And how do we go from moles to grams? Do you remember? You said it.
What's it called? I forgot.
The molar mass. Oh.
Yeah, the molar mass.
That one's the molar mass. Do you remember where you get the molar mass from?
The periodic table, I think.
Yep. All right. So we get the molar mass from the periodic table. And how do you go from moles to moles?
Moles to moles?
Yep.
What
was the other one that you said?
Mole ratio?
Yep. We're going to use the mole ratio. Do you remember where you get the mole ratio from?
From your, I forgot what's it called. Isn't it from the numbers?
Yep, the numbers from our balanced equation. Perfect.
Yeah.
All right. So now that we remember those 2 conversions, those are the only 2 conversions we're actually going to use the entire time. So the only 2 things we have to know how to do is to go from moles to grams and to go from moles to moles. So now let's look back at our problem number 2. And it says we're trying to go from grams to grams. Can we go from grams of one compound to grams of a different compound?
Yes? No?
We can't, just because if we're thinking about things, if I tell you to grab 10 grams of water and then I tell you to grab 10 grams of aluminum, they're not going to be the same amount of particles, so we're not going to have the same volume of information. So we have to go to something else to convert between 2 different things. So our first step then is to go from grams of NCl3. What are we going to try and go to?
Wait, what?
So we're going to start here. Where's our first step going to be? To go where?
Uh,
What conversion are we going to use? What conversion can we use?
molar mass.
The molar mass. So we're going to go from grams of NCl3 and we're going to go to what? If we use our molar mass, what are we going to get?
I don't know.
If we're starting, so if we look up here, if we replace this A with NCl3, what are we going to end up with at the end?
With moles. I don't know.
With moles of?
NCl3.
Perfect. We're going to end up with those moles of NCl3. So we'll end up down here with moles of NCl3. And we're using the molar mass, and the molar mass we're going to use is the molar mass of what compound?
NCl3.
Perfect. Let's just write that in just so you remember. All right. Now, from our two conversions we know from above, can I go from moles of NCl3? Can I go to grams of NH3? Can I go from moles of one compound to grams of a different compound?
Yeah.
Which conversion will we use to go from moles of one compound to grams of a different compound?
The mole ratio?
The mole ratio? What does the mole ratios take us from?
To grams?
So the mole ratio, let's look at it. It goes from moles of one compound. So this would be moles of, remember we canceled that and we turned it into NCl3. Goes from moles of NCl3, and that would take us to moles of a different compound. Could we go from moles of NCl3 if we change this to NCl3? Could we get to grams of NH3 from the molar mass? If we replace, so remember we replaced A with NCl3, so which means this A is the same as this one. These are the same thing. So if this A got replaced with NCl3, this one would be replaced with NCl3.
Okay.
So we can't go using the molar mass, but we can do something with our mole ratio. Because the molar mass we already used to get us to moles of NCl3. So we don't want to use this one again, because we already used this one to get us to those moles of NCl3. Instead, what we could do is we could start with our moles of NCl3. We could use the mole ratio to get to moles of a different compound. From this equation, which compound are we going to want to get to?
To NH3?
To NH3. So this one, again, doesn't work because we don't have a conversion for that. But instead, we can go to moles of NH3. And what are we going to use to get to moles of NH3?
Mole ratio?
The mole ratio. Perfect. All right. Now, we've gotten from grams of NCl3, we got to moles of NCl3, and now we're going to get to moles of NH3. Can we go from moles of NH3, can we get to grams of NH3?
Yes.
What are we going to use to get from moles of NH3 to grams of NH3?
We're going to use the molar mass?
Yep, we're going to use the molar mass. We're going to use the molar mass of what compound?
NH3.
Perfect. All right, so we're going to use the molar mass of NH3 to get from moles to grams of NH3. So now that we have our outline set up, we know what we need to do. Now we're going to draw our railroad tracks and actually solve it, okay?
Okay.
So we're going to draw railroad tracks. And how many steps did we have to take here to get from grams to grams?
3, 4.
We took 3 steps. 1,
Yeah.
2, 3. Which means we need 3 railroad track stops. So we're going to go 1, 2, 3.
Okay.
This one. Yeah. All right. So now, what goes right here?
And NH3?
What does?
NH3, I think.
What
oh no,
always goes first?
NCl3, I think.
What about NCl3?
It goes right there.
What about it though? Should I just write NCl3?
Oh no, 125.
125 grams of NCl3. Perfect.
Go downstairs. Jonathan, go downstairs.
So always put our given right here. All right. Now we have our first step is to go from grams to moles of NCl3 using the molar mass of NCl3. So I'm going to write step 1 right here. Okay. And that means we're using the molar mass of NCl3. So now we need to find our molar mass of NCl3. Do you have your periodic table?
Yes, just got it.
Yeah. All right. Pull out your periodic table and find me the molar mass of NCl3.
All right. $49.46.
You have 49.46?
Yeah.
All right. So from our molar mass right there, okay. Did you find the molar mass of nitrogen?
Nitrogen is 14.01.
Perfect. Did you find the molar mass of chlorine?
It's 35.45.
All right. And then remember, it's NCl3, which means we got to multiply this one by 3 first. So we got to multiply it by 3.
106.35.
All right. So now we take this number plus this number, and we should get our molar mass.
$120.36.
All right. And what are my units for that one?
Grams, moles.
Perfect. What'd you say?
Grams, moles.
Grams per mole
Mm-hmm.
of that NCl3, which, if we remember correctly, means that 120.36 grams of NCl3 equals how many moles?
1.
Perfect. Equals 1 mole of NCl3. All right. So now we have to put our molar mass into our problem. So where do I put my 120.36?
In the bottom.
On the bottom, because we want those units of grams of NCl3 to cancel. So we put the 120.36 grams of NCl3, which means what goes on the top?
1 mole.
1 mole of NCl3. Perfect. All right. That way, those units of grams of NCl3 is canceled. Now we're in moles of NCl3. So that was step number 1. Step number 2 told us that we were using what?
Mole ratio.
The mole ratio, perfect. So we're going to use the mole ratio. And what two compounds do we want to use here?
NH3.
NH3 and what's the other compound we want to use in this mole ratio?
NCO3.
Perfect, NCl3. We want to use the one that we started with, and we're trying to get to the one we're trying to get to. So now, our mole ratio, where do we find the number of moles?
On the periodic table.
Careful, remember the mole ratio doesn't come from the periodic table. It comes from those numbers in front, right?
Yeah.
So how many moles of NCl3 do you need to start with to make this reaction happen? Remember where to look?
Just one, no?
Just one, perfect. Because there's nothing in front, which means that there's really a 1 in front, which means 1 mole of NCl3 is needed for this reaction to happen. And how many moles of NH3 are you going to make?
1, 2.
You're going to make 1 mole of NH3. Perfect. All right. So now, where do I put the 1 mole of NCl3? Do I put it on the top or the bottom?
In the bottom.
On the bottom. I want that 1 mole to cancel. Which means what goes on the top?
The 120? No, I don't think so.
Careful, what are we trying to use here? What step is this? This is the step 2, which means we're using the mole ratio. So if we're using 1 mole of NCl3 on the bottom, what number of moles of what compound are we going to use on the top?
The NCl3?
Yeah, nope, we use the NCl3 at the bottom, which means
no, NH3. NH3.
How many moles was that again?
1.
Perfect. All right, those units of NCl3 have canceled, and now we're in moles of NH3, which means now we need to use what step? Step number 3, which tells us we're using the
moles of NH3 and grams of NH3.
Perfect. Step 3 is our molar mass of NH3. All right, so now let's find the molar mass. Can you find that one for me?
Of NH3?
Yep.
Um, 17.04.
Okay. 17.04 what?
Grams per mole.
Grams per mole. Perfect. NH3. All right, so what am I going to put on the bottom of this line?
17.04 grams.
So I want to put 17.04 grams on the bottom. Then what goes on the top?
1 mole.
All right, and let's double check. Do my units cancel from the third column to the fourth column?
Oh wait. Does the 1 mole NH3 goes in the bottom?
Perfect. We're actually going to flip them. So we're going to put the 17.04 on top, and the 1 mole on the bottom. That way those moles of NH3 can cancel. And the units that we're left with are just grams of NH3, which is what we're trying to find by the end of this problem. Okay? So once we do that, what we do is we're going to multiply everything on top together and multiply everything on the bottom together. So we're going to multiply 125 times 1 times 1 times 17.04 divided by whatever's on the bottom, so 120.36 times 1 times 1, and we should get our answer.
17.69.
And what are my units going to be?
Grams of NH3.
Perfect. And we can even double check because the answer's right there as well. And did we get it right?
Oh, yeah. Okay.
Does it make sense?
Yes.
Do you have any questions about it?
No, I think it's all of them are gonna be like this, right?